So we are going to look at aspirin. And as you probably know, aspirin is used as a painkiller. Or actually, it has two main uses. It's for elevated pain, fever and swelling. Or it's also used to reduce the risk of heart attacks and strokes. But before we go more into aspirin, we want to know where it comes from. So actually many years ago, they used bark from a willow tree as painkiller. And what they found out was that the working compound in the bark of the tree is actually this compound over here. So we start with just drawing a benzene. We put a carboxylic on top. And then we have a hydroxyl group. And this compound here is called salicylic acid. Salicylic acid. So this is the main compound that worked as a painkiller from the bark of the tree. But actually what they found out was that this compound irritates both mouth and stomach. But then they found out that they can add another compound. So with adding this compound over here, and this compound is called ethanoic anhydride. And what they found out when they added these two together was that we start with the salicylic acid again. We add the carboxylic acid on top. So this part isn't changed at all. We keep the oxygen. And then we add this group right here to the oxygen. So we add that group, and what we actually end up with is an ester. We see here that we have an ester now instead of the hydroxyl group. So actually this new compound here is called aspirin. So this is aspirin, this compound. And originally we start with bark from the willow tree. We add a compound to not irritate the mouth and stomach, and we end up with aspirin, which we know today as a painkiller. We do have something more, so we are actually left with this part here. And we do add a little bit of acid as well to get the reaction started as a catalyst. So we do still have this part as well. So we have made a new acid because this part have left and we have added the hydrogen here. So we end up with this. So this is just a byproduct. This is what we're looking for, the aspirin. So actually what aspirin does is that it blocks the signal to the brain. So the brain doesn't get the signal of that it's hurting somewhere in the body. And after we have made this aspirin, so I made this one and we want to check if it's pure or not. So we are going to look a bit about the purity of aspirin. And how can we know it's pure? So actually we have three different ways of finding out. The first one, and probably the easiest one, is checking the melting point. So when do this start to melt? So we check the melting point, And the melting point of aspirin is supposed to be from 138 to 140 degrees Celsius. So if you think you have made aspirin in the laboratory, you can then take a melting point test and see, does it melt in between these values? If not, it's probably not pure. If it does melt, it's probably pure. The next thing we can do is to check for the something called the thin layer chromatography. Thin layer chromatography. So thin layer chromatography, it actually looks like this. It looks like a small paper. When you add 1 dot of whatever you have made, hopefully aspirin and hopefully pure aspirin, you put it in a solvent and you wait a little bit. And what you will get then is multiple dots a little bit higher up on the paper. If you only have 1 dot, then it's pure. If you have multiple dots, these other dots have to be something else than aspirin. So thin layer chromatography is another way to check if it's pure or not. The third way is to use the infrared spectroscopy. IR for infrared spectroscopy. So we use IR spectroscopy. And do you remember from chapter 11.3 what this one looks like? So you probably have something like this. And you have some values down here, parts per million. Let's say we have 4,000 over here and we have 1,000 over here and the values in between. And you have something looks like this. So you have something here and then multiple dots down here. And we can check, so we know that this one over here is for a hydroxyl group. And if you have a peak here, it can be ketone. So we can check for the IR. And we can actually compare with IR specters from pure aspirin. And if it looks the same, then it's probably pure. So this is how to check the purity of aspirin. These 3 methods. And so when you take aspirin, you do have some side effects. Some effects that we don't want, but that can happen. So we are looking at the side effect. So the side effect of aspirin is actually stomach bleeding. Stomach bleeding, that is quite common, especially if you use aspirin over a long period of time. And then you have something called Reyes syndrome. Reyes syndrome is only if you take aspirin as a child, and it's not common. But what can happen is that it affects the liver and the brain. And it's actually a quite dangerous syndrome. So taking a lot of aspirin as a child can have an unwanted side effect. It's not common. And the last side effect of aspirin is actually if you interact with other drugs. Like alcohol. And what can happen if you interact with alcohol, so if you take aspirin and alcohol at the same time, you can actually have gastrointestinal bleeding. And these also, if you take those two together, it's a quite common side effect. So do not mix alcohol with aspirin. And the last thing we're going to look at is the solubility of aspirin, and actually of many types of drugs. So, soluble. So actually aspirin is quite insoluble in cold water. But what we can do, we can make it as an ionic salt. So then it will look like this instead. So we have the group here, the ester, CH3, which doesn't change that part. And we have the acid. And instead of having OH, we have O minus. So this is the ionic part. We take away the H plus and we're left with O minus. Now we have the aspirin as an ionic salt. Or this is just ion. So if we take it together with Na plus, for an example, this will now be an ionic salt. And actually, what happens is that this salt is soluble. It's good soluble in water. And actually what happens is that the aspirin now reaches the stomach quickly. And also that means that it reaches the bloodstream faster. But it doesn't change the bioavailability. And do we remember what that is? That is actually if the drug we are taking is reaching the place in the body where it's supposed to go to. So if we say that the bioavailability is 50%, that means that 50% of the drugs actually got to the place where it's supposed to be. So the bioavailability doesn't change. It's just that it starts to work faster. So this is the main part of aspirin. The most important to know. We do also have other painkillers that you probably have heard about, like paracetamol and ibuprofen. So those are a bit weaker, but also with less side effects.